A lot of people think that Google is one of the companies that just makes some of the best code in the world, and they do. They make some really good code, but they also make some really not so good code. Welcome back to another episode. Today I'm going to talk about a release of PKTD and the Packet Lightning Daemon, which is coming imminently, but I'm also going to talk about the gRPC system of Google and why we removed it. So the idea of gRPC is that you can make a request from one program on one computer to another program on another computer. It's called remote procedure call. You're calling a procedure on a different computer. And this is very useful because that way you can have a program running on one computer and it's asking another computer to do things in a very structured way. Now, that's RPC. gRPC is a design of Google, and they aimed to create a standardized RPC system for their software that runs inside of the Google sphere. And a lot of people, most everything that Google makes is open source, and a lot of people think, oh, well, I'll just use it because Google made it, so it must be good. And those people are unfortunately wrong. So why is gRPC a mess? Well, I can start with the really obvious problems. For example, the Java gRPC client, which we tried using in Android, not only did it not really work in Java, but we ended up causing actual crashes in the gRPC Golang server by making requests from the regular Java gRPC client. And in case anybody wonders, well, any RPC software, any network connected software should never crash under any circumstances, even when it's receiving malicious requests, malicious data that is designed to cause it to crash. It should not crash. So the fact that this gRPC can be crashed by sending it what is basically a legitimate request from a legitimate client library tells me that this software has never really undergone any serious testing. Number two is that gRPC is just buggy and it's difficult to integrate in different platforms. And a lot of this is because the API is what we know as opinionated. An opinionated API wants you to use it the way it wants to be used. And this makes sense. Inside of a corporation like Google, they want everybody doing everything the same way. And so their code is going to have an opinion about how you write your code. Well, that's not necessarily the right thing for us. We need to be able to, for example, make requests from our Android and iOS application to control the Packet Lightning Daemon. And when we're making those requests, well, we're making them from either Java in Android, or we're doing it from React Native on iOS. Well, but many platforms don't even allow HTTP 2 unless it's in SSL encryption. So now you need SSL, and now you end up needing a certificate from a certificate authority just to be able to send a message to an application that's running on the same computer. So in our case, gRPC is how two programs on the same device talk, not how two devices on the same network talk. So we're using it in the context, or the LND software from which Packet Lightning Daemon comes was using gRPC in order for the client to control that Lightning software. So in our case, it didn't make any sense because we couldn't control it from inside of a web browser without using HTTPS in order to be able to use HTTP 2. Finally, gRPC is just not conducive to debugging and testing. It requires the use of the protocol buffer's binary format, which is great for sending messages between programs, but it's not great for just figuring out how something works and playing with it. You can't create a binary message just from the command line like you can create a JSON message. So gRPC, overall, it's kind of a fail. It's not really solving our problems, and I don't think that it's used that widely inside of Google. There's probably some teams that are using it. There's probably some people who would be upset about watching this video, but it also indicates a bigger thing, which is that you find a piece of software written by a large company like Google, and just because it's written by a large company, even if they say we support this or we stand by it, it doesn't mean that it's something that you can just adopt. A lot of people adopted AngularJS, another Google project, only to find that Google just walked away from it and decided to build Angular 2. So it's really caveat emptor with whether you're going to adopt a piece of software or not coming from one of these large companies, because a large company, they can just decide that they're not going to support it anymore. They can say, they can cancel that project. Whereas if it came from an active community, the community isn't likely to just disappear. So that's what I have to say about gRPC. Now, the Packet Lightning Daemon, we ripped out gRPC and we replaced it with a very simple HTTP server. Now it's just HTTP 1, that's the no encryption, very simple, because in general, either we are going to be on the same machine, so encryption is not necessary, or if we're on different machines, we're going to put it behind a regular web server like an Apache or an Nginx and let that do the business of the encryption, because then that's going to be the part that's going to use Let's Encrypt. That's the part that's going to be doing the certificates and all the business of that. And that's a web server that's meant to do that, and that can be configured with the web server config. So we generally would not want to have our server, our wallet server, the Packet Lightning Daemon, actually be internet facing. We would rather put it behind a web server so that we have that extra flexibility. So what we did is we have now we have a very simple HTTP protocol. It still uses the protocol buffers data structures. However, it allows the client to request in binary format and send a binary data structure and then receive back its response in binary, or it can send a request in plain text in JSON representation. So it's very nice that you can make requests using a regular curl on the command line and using something like a Postman or something to be able to make requests to the server. So that's what we did. That's one of our biggest accomplishments in the release that is imminently coming of Packet 1.6.0, I believe it's going to be. And other than that, we have made improvements. We've fixed bugs, and we pretty much have it to the point where all of the new wallets can use the Packet Lightning Daemon instead of using PKT wallet. So we're pretty excited about moving in the direction of the Packet Lightning Daemon, and with this new JSON / gRPC based protocol, which, by the way, one of the really exciting things about that protocol is that if you send a request for help, it will describe all of the RPCs that you can request, all the functions that you can request from that wallet. It will explain them to you. The server will actually send that back in a JSON structure, and you can request help from one of those, and the server will explain you all of the things that you can send and what they mean. So that's really exciting, and that's all generated from the protocol buffers files with parsing of the comments. And that way, it's only written in one place. We eliminated, basically, there was 3 places that everything was written, and we condensed it down to where it's only written in one place. So that was a big move forward. And going forward, we're working on the AnodeVPN app, which, I showed that last week. And the AnodeVPN app really only got off the ground once we got rid of gRPC. gRPC was holding back the AnodeVPN app. We just couldn't get it integrated into Java. It just was slow. It was causing crashes. It was impossible to debug. And then once we got rid of gRPC, all of a sudden everything started taking off. So it's a lesson for people that, just because something is supposed to be the good way to do something, it's recommended by a big company. You need to use common sense and use good judgment when you're looking at software. There's a lot of libraries that are opinionated. There are a lot of libraries that don't have any actual testing in them. It might be used by one team in one project, but it's not widely used internally. You have to use common sense, and you have to be suspicious of any software that you're adopting in your open source project or whatever projects that you're working on. I hope you liked the video. If you did, please give me a thumbs up. Comment down below if you have other experiences or other thoughts about adopting software, or if you have other questions about the Packet Lightning Daemon and the new stuff that's coming out. And keep being awesome, and we'll catch you on the next one.